Why does the giant barge float but the rock doesn't? So the barge is less dense, has air in it. And we said that the water causes you to float a little. Not necessarily all the way float on the surface. You can still stand in water, but it's always going to be making you float a little bit. Okay, so what is the buoyant force? So the buoyant force is a support force on objects in a fluid. Think of it a little bit like normal force, but it's caused by a fluid. And the reason for it is pressure differences between the top and bottom of an object. So, I've got an object in the water. Okay? And here's my object. And it has pressure pushing on it in all directions, perpendicular to the surface. So there's pressure pushing this way, there's pressure pushing this way, there's pressure pushing down, there's pressure pushing up. What do we know happens to the pressure as you get deeper? More. Yes. So, should there be more or less pressure under the object than above? There should be more under. So the pressure underneath is larger than the pressure up, which means you get a net force up. That's why you float. You float because the pressure under you is more than the pressure above you. That pushes you up, and when you go up into the air, or not up in the air, when you go up through the fluid, that's the buoyant force on it. Now, there is always a buoyant force. I want to make sure you understand this. The buoyant force doesn't mean it automatically floats. Every object has a buoyant force in fluid, but not every object floats. We'll talk about why objects float here in just a little bit, but not every object is going to float. Okay, so there's a phrase that you're going to hear me talk a lot about, and that's called volume of displaced fluid. It's the amount of fluid pushed out of the way by the object. And the volume of the displaced fluid will always equal the volume of the submerged object. So volume of the displaced fluid will always equal the volume of the submerged object. This doesn't work if it's floating. If it's in the water, it works. Okay? So the volumes of those things are always equal. The amount of fluid pushed out of the way is equal to the amount of object that's there. Which makes sense, right? If I have a 3 cubic meter object and I put it in the water, how many cubic meters get pushed out of the way? 3 cubic meters. Shocker. Okay? All right, so let's do an example. A wood cube floats in a tub of water. So let's draw the forces acting here. So we've got our tub of water. And we've got our wood cube. What are the forces acting? Gravity, obviously, and buoyant force. So, let's use our good friend F equals ma. What are the forces? Buoyant force up minus gravity down equals mass times acceleration. It's floating, so there's no acceleration, so it equals 0. Add Fg to the other side, and oh my gosh! Buoyant force equals gravity. Which makes sense, right? If the object floats, the buoyant force up has to equal the gravity down. That's what's going to happen with y'all. Your buoyant force up from your boat should equal the gravity of y'all down. Okay? So, you have to make sure that your boat can apply a large enough buoyant force. If your weight down is 200 pounds with you and the boat combined, then the boat has to apply 200 pounds of force up. Oh, it's not going to work. Where are we time this? Oh, we're doing good. If the volume of the cube is 10 cubic meters, half the cube is submerged. What's the volume of the displaced water? Half. If half of the cube is in the water, then half of that is displaced water. So it'd be 5 cubic meters. Okay, so let's look at Archimedes' principle, and then we'll see where we are. Archimedes' principle is the following. Buoyant force equals weight of the displaced fluid. So the buoyant force equals the weight of the displaced fluid. The equation is this. Buoyant force equals mass of the fluid times gravity. Notice it's not mass of the object. It's not mass of the object, it's mass of the fluid. That's not the only equation I'm going to give you, though, because I'm a real stand-up guy. Okay? So Archimedes was a philosopher back in the ancient Greek time, and he was experimenting with floating objects. And he found that the weight of the buoyant force, or the buoyant force, was always equal to the weight of the fluid that got pushed out of the way. So what he did is he would weigh the object, then he would push the water, and then he would put the object in the water, and he would let the water flow out over the cup that he was putting the object in, and he would weigh the water that fell out. And it turns out the weights were the same. And so that's where he got this. He was the one who coined the phrase eureka. He made up the word, and he said it when he came up with this. So there you go. Little something for you to chew on. Here's the other equation. So this equation only works if you know the mass of the fluid. And let's be honest, you don't know the mass of the fluid very often. You know the mass of the object. So here's the equation you can also use. Buoyant force equals density of the fluid times the mass of the object over the density of the object times gravity. These are all things that you will know. You will know, or you could solve for. You will know the density of the fluid because it'll be in water, it'll be in salt water, it'll be in oil, it'll be in something you know. The mass of the object you can measure or solve for. The density of the object you will know or could solve for. And gravity is 9.8. So these are all numbers that are easier to know. The mass of the fluid is hard to know. You have to have a very particular apparatus to do that. Okay? You have to have an object you have to have basically a cup inside of another cup so that the water has to be all the way at the top of the cup, and then the water goes out over the edge, it goes into the bigger cup, and then you weigh that. It's a bit of a pain, so we're going to use this equation, which is a shortcut one. Okay? Go to the back page. We're just going to do just a little bit. Almost done. Just a little bit. I'm bishing more. Okay. Explain how buoyant force on a block is different if the block is partially submerged or if it's fully submerged. Where do you think the buoyant force will be more? If it's all the way under the water or if it's part way under the water? All the way under the water. So fully submerged has more buoyant force. Yeah. So submarines can control their buoyant force by either taking water into their tanks or pushing water out of the tanks. So when they push water out, they become more buoyant and they'll float. And when they take water in, they become less buoyant and they'll sink. Yep. So they can control what their buoyant force is. Okay. Explain how a 50-meter Newton object could feel like 30 newtons. So if you've got an object under the water sitting on a scale, if the gravity down is 50 newtons, there are two forces acting up. There's the normal force from sitting on the surface, and there's the buoyant force from being in the fluid. If the buoyant force equals 20, then normal force plus buoyant force minus gravity equals 0. Add the 50, or 20 and 30 is negative 30. Add that to the other side.